Hi everyone, Senan this side, and in this video we are going to solve this number of enclaves question on LeetCode. So what you are given is a m cross n binary matrix grid where 0 represents a C cell and 1 represents a land. A move consists of walking from one land cell to another adjacent 4-directionally land cell or walking off the boundary of the grid. Return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. So basically we need to find an island which is basically surrounded with zeros. Fine. Now in this case you have these three elements, right? And these are surrounded with O's, right? This and this. So this surrounds them. But in this case this one is not a part of an island because you could get off the grid by going left. Although it is surrounded up, down and right, you can just fall off the grid on the left. So this is not what we are looking for. We are looking for a group of ones such that these are surrounded by zeros, such that you cannot walk off the bound of grid in any number of moves, right? You can only stay on one. You can move left, right, up, down, whatever you can think of, but you can never ever get off the grid. And this is what you need to find, is the number of ones like this. Okay, in this case you see these two are connected with the edge, so you can walk off these two ones. But if you are on this one, you can go to this one and you can again fall off the grid. For this, the same case, you can go here and follow the grid. Maybe go here, come back, go here, and then get off the grid. So at some point you would get off the grid. Now the question is, how do we actually see that? So this question is exactly same as my previous video or previous to previous video, where you have to find x's and o's, and you needed to find the o's such that those are bounded by x's. So the logic would be exactly same. It's not even different, right? The only thing you have to return in this question is the number of ones. In that question you had to modify the grid. Now obviously we are going to use a depth first search traversal because this is not a matrix problem, but it's a graph problem. You need to do a breadth first search or depth first search. Either of them would work, and I would go by DFS because it's easier to implement recursively. So the point is, any one which is at the boundary and any ones which are directly or indirectly connected with the boundary one cannot be a part of our solution. Clear? So that is fine. So what I do is I go on the boundary, right? And whenever I find one, I do a DFS traversal and I change this one to 2 to keep track of that I have visited this element. So in this question I am not using a separate visited array. I am doing everything in place in this grid itself. Although later on I am restoring that same grid again, but initially I am taking this grid itself as my visited array or the visited matrix. And I am able to do this because we know that grid I and j is either 0 or 1. So if I say 1 as 2, I know that I have visited this before because it cannot contain 2, and if there is a 2, that means I have placed that 2. So that is how I am keeping track of the visitedness of a node. Now I get the rows and columns, and if you see, these are the dr and dc, that are basically delta row and delta column. That is basically useful for us when we are looking for the neighbors of a node. That is, using this we can easily write a for loop. Now what I do is, if you look at this for loop, I'm checking all this, the first row and the basically the first column and the last column, and if there is a 1 in any one of them, what I do is I call a DFS on that node. In this case I'm trying to do for the first row and the last row. In that case I again call the DFS. So this is me calling DFS on the boundary nodes. So that is why we call this as a boundary DFS or boundary BFS if you are implementing a breadth first search solution. Now let's look at the DFS code. So how am I implementing that? So I take a row, I take a column, I take delta row and delta column just to keep track of which directions I am going, which we are going to see later on. So I get the size row m and column size n, and since I am visiting this node, that means this grid row comma column was actually 1 initially. So I update that to 2 in a way that is telling me that I have visited this node. Now I go into all 4 directions. I calculate the row and column. Then I check if having this new row and new column, I am still in the grid or not. So if you check this 0, I can go up, and if I get a value of row as -1, that means I'm not in the grid at all. So if and only if I'm in the grid and that grid value is 1, that means that one is somehow connected directly or indirectly with an edge node which has a value 1. So in that case, I would call this DFS again. So by this, I would find all the nodes that are connected with the edge somehow, and through that I know those nodes cannot be a part of a solution. Now, after doing all this, all the nodes which are connected with the boundary, those values would be covered with 2. And if there is a 1, that means we cannot. So if I do it on this one, this node would be overwritten as 2, and these 3 would be 1 as it is, because in no DFS call we would be able to get here. So using this, I can go here, here, and here, and since all 3 being 0, I cannot actually get out of this, right, or get inside this island. So after this 2 DFS, the boundary DFS calls, I say initialize the count as 0, and what I do is, if I see at some point if grid I of j is 1, that means I was not able to go to that place using the boundary DFS. That means that node is not at all connected with the edge using any one, right? Otherwise, if else if this is 2, that means I had visited this was 1 initially, right? So I subtract 1 to get this value back as 1, and in the end I just return the value of count, and that would be running fine. So the test cases are accepted, as well as if you see this, this is also accepted. So what is the time and space complexity? So I would say that time and space complexity would be exactly what it is of DFS, which is big O of n square. Time and space complexity both. I've discussed this in my 3 to 4 previous videos, exactly why that is the case. The time complexity and space complexity would be both big O of n square. Maybe a constant factor would be multiplied with that, but that is that's ignorable basically. So this was the whole video about. Thanks for watching, and if you think this video might be useful for someone else, be sure to share it with them, and thanks for watching. Bye.